Welcome back again. This is part 2 of a two-part video on access control lists. In a previous video, we talked standard named and numbered access control lists, and please feel free to reference those for explanations of why we use access control lists, what they are, etc. In this video, we're going to talk extended. Okay, so difference being with extended, we're not as limited as we are with standard access lists, mainly because we can now implement source and destination IPv4 addressing, specific protocols, transport mechanisms, TCP, UDP, etc. So we are going to focus this lab on that. And with that being said, we're just going to jump right into it because, again, for an explanation on how this is set up and everything else, please refer to my video on standard named and numbered access control list, and it'll walk you right through that. Okay, so for this one, what I did was R1 and R3, they are fairly bare. In this case, we should still have our route. So we just have one static route getting us between networks, and that way our containers can ping back and forth between one another, so we're good there. I have negated, I believe, all the loopbacks off of both of these routers because we are going to use those loopbacks again. Oh, no, I didn't. But that's okay because we're actually going to use router 3's loopbacks in this case again. And we're going to talk about our numbered extended access control list for our first iteration here. Okay. Now, to do that, what we're going to do is, since extended gives us the option to focus on protocols, what we're going to do is we're not going to focus just on IP addresses. All right, we're gonna assign some actual protocols now. Specifically, we're going to talk some TCP protocols. We'll talk SSH, and we're going to talk ICMP a little bit. Okay, ICMP being its own protocol. So, with that being said, we'll maintain our IP routes. We'll keep our loopback addresses on router 3, so we're good there. So let's dive right into it. So the first thing that I want to do is I need to get these devices configured for SSH. Now, I'm not going to go through exactly how to configure SSH on a Cisco router because that's something that I feel you should already know. But what I will do is in the description, I will copy and paste my router configs. That way, if you did need to have some explanations there for you. Okay, so let's start with router 1. Let's get into global configuration, and on router 1 we'll configure SSH. I'm just copying out of a text file. Don't judge me. So we'll go ahead and do this. And we are good for SSH there. Actually, the Catalyst 8000V routers actually come with SSH enabled right off the bat. However, you don't have any users, so that's still, and you don't have any domain names and that good stuff. So you still need to do that. All right. But at the end of the day, we can see show IP SSH. We are enabled. Okay. So we are good to go, and yeah, we should be good. Let's see. So let's go to router 3, and we'll go ahead and configure SSH for it as well. So let's go ahead and get that set up. From here, I'll get into global configuration. Okay. And SSH has been configured. All right, wonderful. Let's give it a test. So, I don't know. Let's start with Docker 2. So let's see. Can we ping 10? Or I'm sorry. Can we ping 1.1.1.1? We should because it's its gateway. So we should be there. So let's try to actually SSH to it. So SSH. My user I created was called test. And then at 1.1.1.1, we're not going to identify any offering algorithms or anything like that. We're just going to add our key, put in our password of Cisco123, and we're in router 1. Okay, cool. So now let's try router 2. So SSH, same username, test at 10.1.1.2. Let's go ahead and add this key, input our password, and we're in router 3. All right, so that could be a good or a bad thing. So, hey, great, we can SSH all over the place. That helps when we're trying to troubleshoot. So sometimes you want that open, but sometimes you don't. Okay? So, you know, we're going to go through how we can kind of limit who can SSH, because you don't want just every engineer on the platform saying, hey, I'm going to SSH to router 1. It's like, why? You do software. Why are you consoling into our network? But anyway, first, let's focus on pings. Okay? So what we're going to do is we're going to hop over to router 3, and we're going to ping router 1 from our loopbacks just to see what we got. So we're going to ping 10.1.1.1 in general, so we're good there. But now we're going to source from loopback, and you can see right there, it's on the screen, loopback 10. We're good there. Let's do loopback 20. We're good there. Let's do loopback 30. All right, and we're good there. Okay, so with that being said, right, in previous video what we did was we actually had to identify the actual subnet, all right, and we had to do that by the IP address itself. Now, we're still going to kind of do that, but what we're going to do here is kind of talk through how to identify the access control list by protocol, okay? So the way we do that is, since we're going to be limiting traffic coming from router 3, we're going to want to implement the access control list on router 1 and then place that rule on the inbound interface, which in this case is gigabit Ethernet 2, and apply it to the interface. So let's start with router 1. Let's get into global config, and we'll hop right into it. So again, I harp very heavily on remarks. So yeah, we definitely want to use those remarks. But what we're going to do is we're going to use, oh, sorry. Oh, that's all right. No big deal. Sorry about that. Okay, let's do access, and we're going to do list. All right, again, this is going to tell you which is standard, which is extended. All right, so in this case, we're going to use a numbered extended. So the number I'm going to use here is 150. All right, that gets me within extended range. All right, so what I want to do now is I want to make a remark. Okay, so what I want to do is I want to permit pings from router 3 loopback 20. Okay, so I'm just going to remark that, and I can actually tell myself, hey, this is what I'm doing. Because again, the number 150 only tells me, hey, it's an extended ACL. It doesn't tell me anything about it. So I'm going to make remarks so I know what I'm doing here. All right, so, okay, we've got that remark in. So now here is the actual access list, and we'll talk through it in a second. So for the actual access list, it's kind of cut off here, but it's the full command access list 150 permit. You can either deny permit. All right, and then what we're going to do is we're going to identify the actual protocol, which in this case is ICMP. All right, and we're going to say this, we want to permit from this specific source. All right, in our case, it's loopback 20, so 10.20.20.0/28, so our wildcard is 0.0.0.15, okay? And then we're going to say which host we want it to ping. So this is that extended gives you the possibility for a destination. And in our case, 10.1.1.1 and then a /30, okay, which is 0.0.0.3. And if you notice, Normally you would have like an equal, but in this case we're just going to do echo. All right, and if you look here, I can actually do a question mark, and if we see echo, echo is ping. Okay, so let's do that, and we'll just type in echo. All right, so there's that. Okay, so we've done that. Now, I don't want pings coming from anywhere else. All right, this is, in a lot of environments you're going to have ICMP shut down. All right, they don't. Many customers will not want ICMP enabled because to them it can present as a security vulnerability. All right, because this is how attackers identify whether or not a link state is active. All right, they'll ping it. And if they can't use regular ICMP, they may use ARP ping. All right, so focusing on the layer 2 aspect. All right, so again, they want to shut it down. So what we're going to do is we're going to pretend we had a customer that said, hey, I only want to be able to reach it from this interface only, or this subnet only. I don't want anyone else being able to ping my system. So what we'll do is we'll go ahead and we'll do a remark, access list 150 remark, shut off pings from other endpoints on remote LANs. All right, so we'll go ahead here, and then we'll do an access list. We have to identify the number again. This is kind of the annoying part of using extended numbered, because you have to continuously put the number. And now we're going to deny. All right, so we're going to deny, and then we're going to focus on the protocol. All right, in our case, ICMP. All right, so we're going to deny ICMP. All right, and now the next portion is from who? And our answer is from anyone. We've already said who can ping our device and which address specifically. Okay, so with that being said, we don't want anyone else. So we're going to write any here. And then from here, we're going to identify the address for which we don't want reachable, right? Which is the same as what we had before, which is our 10.1.1.1. And then we're going to identify echo here, just like this, okay? And then again, so access lists, they almost have that default last statement, but for them it's because if you just implemented it like this, you're shutting down traffic everywhere else. So you don't want that. So we have to make sure that we explicitly indicate that we're going to permit all of our other traffic. So make sure you put a remark, and I'm going to write permit all other traffic, access list 150. And then the last statement that we're going to be responsible from here is access list 150, permit IP any, so source any, destination any. All right, and we should be good there. So again, we have to apply this to our inbound interface. So we'll go ahead and we'll run into Gigabit Ethernet 2, and then we'll put our IP access group 150 inbound. All right, so now that ACL is in play. Okay, so let's double check, and we'll make sure our ACL is working. What we can do here, we can do a debug IP packet, and then we can do a 150 detail. Okay, so we now have packet debugging on. All right, so from router 3, what I'm going to do now is let's try to ping. We should only be able to ping from Loopback20. So let's actually do that first, just to make sure that we can. All right, so we have 100% round trip. We're good. Okay, we aren't seeing any debugging yet, and I'm not sure. I'm pretty sure we should, but let's try to hit it from 30. Okay, so now we're getting that administrative, hey, we're blocking you kind of thing, right? So we're still not seeing any debugging going on router 1. Either way, we know that the ACL is in fact working because We're getting those administrative no thanks, you're not welcome kind of thing. All right, so we're going to leave that as such, and just to kind of prove that out before we were able to reach our router, what we do want to make sure is we're not cutting off other traffic. So we should still be able to reach our other side of our network, and we can, which is great. That's awesome. That's what we want. But can we ping 10.1.1.1? And as you can see here, our packets are being filtered. That means that our ACL is in fact working. And that's what we want to see. Okay, it's not responding. So that that we know is working, and we're looking good so far. Okay, what we'll do here is we're not seeing any debugging, so we'll turn this off. And now what we'll do is we're going to get into router 3. Okay, now looking over at our extended. Okay, so for our extended ACLs, we want to apply them near the source. Okay, so what I'm going to focus on here is not so much cross-network connectivity. What I'm going to do is give you a real-life scenario. So you have a router, it's your gateway, say, and you know your network engineers have to be able to get to that router. If they can't reach it physically with a console cable to console into it, then they're probably going to SSH into it from afar, right? But we don't want everybody else SSHing into that device, okay? Let's just say we have a dedicated SSH machine here, and that machine is, I believe, Docker 3. All right, so yeah. So this is our SSH machine. This is what our network engineer uses to SSH into all the network devices. So what I'm going to do is I'm going to get on router 3, and we're going to implement a access control list on this router as close to the source as we can. Okay, and we're going to stick with the 150 scheme. All right, but what we want to do is we want to remark that we're only permitting from Docker 3. All right, so let's go ahead and indicate that now. All right, so in this case, we're talking about a single host. Okay, so a single host, when it's an IP address, we're talking about a /32. All right, so looking back at our little map here, if you have a single host which is a /32, then you basically have this line subtracted by itself, so it's going to be 0.0.0.0. Let's move this back up. All right, so let's go ahead. What we're going to do is we're going to say we're going to permit 2.2.2.4 as being able to SSH to this device. Okay, and we identified the wildcard here, so we're talking with single host, and we have identified port 22. So that is SSH, well-known port, right? Now, what we want to do is we want to make sure that nobody else is able to SSH to our router from the network. So let's go ahead and make a remark that we're going to deny other endpoints on the LAN to SSH, all right? And then we'll use the same statement, 150, and we're going to deny SSH from any source to any destination, okay? And we'll go ahead and implement this. And then again, we have our default end statement, which is permit all other IP traffic. So that's basically just your access list 150, permit IP any. All right, and we remark that we're going to permit all other traffic. Okay, so let's go ahead and we'll do GI. In this case, it's interface gigabit 1. All right, so this is an inbound rule, so we'll do IP access group 150 and then in. Okay, so now coming over to Docker 3, let's see if we can SSH. SSH test is our user at 2.2.2.1. Okay, and our password we implement, and we are in router 3. All right, so that's good. We're able to maintain access there. Okay, but let's try Docker 4. All right, so from here, can we SSH test at 2.2.2.1? And obviously we can't because we have an ACL in place. There's no yeah, we're blocked from this. All right, and just so you know, I did test this prior to implementing that ACL, and Docker 4 was able to get in via SSH, no problem at all. Okay, all right, so that's a very, very quick down and dirty on numbered. All right, now let's talk about named ACLs, named extended, I should say. All right, and we're going to focus on some routing protocols now. Okay, so what we're going to do is first and foremost, we are going to create some loopbacks. Well, actually, first let's get rid of. Let's do no. We're going to negate this command. We'll exit, and then we will do we'll just do no IP access list 50. Access list 150. Oh, sorry. Extend 150. Okay, that's better. Do show IP access list, and we don't have any. All right, looking good. Okay, so what we're going to do now is we're going to configure some loopbacks on router 1, and they are right in the diagram. And we're going to get rid of that IP route. We're going to get rid of our static route because now we're going to be using some dynamic protocols. So we'll get into global config. We'll go ahead and give ourselves some loopbacks, and then we're going to negate our static route. Okay, done there. Sounds good. The next thing that we want to do is we're going to create two instances here. We're going to create a EIGRP protocol and an OSPF area. Okay, so we're going to be running both our EIGRP and OSPF on our routers, and it will make sense why when we get to it. Okay, but all I'm doing in this case is I'm adding several networks inside of EIGRP, which are mainly focused on our 10.1.1.0.30 network, and then I'm going to include my local area networks on both sides. Okay, but in addition to that, I'm going to be selecting specific loopbacks that I want in those different routing protocols. So EIGRP is going to have this address right here, and then OSPF is going to have all others. Okay, it'll make sense in a minute. Let's go ahead and get our console back up. Okay, so on router 1, I'm going to create two of these routing protocols. So we'll do EIGRP, and then we will do OSPF. Okay, and again, we'll focus more on EIGRP and OSPF in future videos, but for now, we're just going to use them as examples. Okay, so we'll go ahead and leave router 1 alone. Now we'll head over to router 3. Let's open this up a little bit so you can see. We're going to take this static route out. We're going to negate our loopback interfaces, and then we're going to create EIGRP and OSPF protocol groups on this router as well. So let's go ahead. Okay, let's do this. Here we go. All right, so here we go. We're good, and we should be seeing. Great. So well, OSPF actually moved pretty quick this time. That's amazing. Normally it takes a bit to converge, and EIGRP does a better job at it. But either way, show IP OSPF neighbor. Wow, we're fully converged. So we are already in that state, which is great. Okay, so we took our static routes out. We implemented our dynamic routing protocols. Can our networks still reach each other? Let's go to Docker 1. Can we still ping across? Yep, we sure can. All right, that looks good. For Docker 4, can we still ping 1.1.1.3? Yeah, we can. All right, everything looks good. So we put our routing protocols on. Okay. Now, what we don't want is router 3 is is going to be pretty specific here. All right. It's going to be specific in saying I only want certain routing protocols running on my device. Okay. And with that being said, we're going to put some access control list in because I only want I only want EIGRP running. All right, I don't want OSPF. It's just my customer has different requirements, whatever. We do want to maintain these configurations as a backup, but I don't want them on now, and I want to be able to quickly get that access list off if I needed to. All right, so what we're going to do here on router 3, we're going to go ahead and get into global config. Okay, and we're going to do an IP access list, and we're going to now do a name. All right, so it's going to look extended, and we're going to call it routing ACL. Just like before, we're going to give it some great remarks, and as I just indicated, we want to deny OSPF, and I'm going to put the protocol number in there so we could see it. All right, IP protocol 89. Looks good so far. And the reason I do that is because in the actual deny statement, we're going to use the protocol number. So you could see how my remark just saved me some research time if I didn't remember offhand. Okay, so let's go ahead and we're going to deny 89 any. So any source, any destination. We're good there. But we do want to permit EIGRP, and then we're going to do the same thing here in that remark. We're going to identify the IP protocol number. So we're going to permit EIGRP, and again, in our permit statement, you're going to see we're going to permit 88 any. And that's exactly what we want. And just with what we had talked about with ACLs and their implicit permit, we're going to make sure that we implement that too. And we should be good to go. All right, so we're good here, and I just want to quickly point out that right now, without assigning this to an interface, we still do have an OSPF neighbor. Okay, so that and that neighborship is not going anywhere. It will once the dead timer expires. But let's go ahead. And we will apply this to interface gigabit Ethernet 2. That's our inbound. And that's where the hello messages are coming across right now from its neighbor. So what we'll do is we'll do IP access group, and then we're going to have to call it what we named it. So that's routing ACL, and it will be inbound. So we're good here. Okay, great. Now, once this dead timer expires, we should notice that neighborship will go down. And that's really what we're looking for here, because what we want is we want EIGRP to pick up the routes. Okay? There's certain networks that are not going to be able to be reached. Okay? The way that we can kind of talk through that is if we looked at, let's see, right here, we'll look on router 1, and we can see show run, and we'll do section OSPF. So here's our networks. We identified one of our loopbacks, 4.1, right? So is router 3 able to reach 4.1? Let's find out. So let's see if we can actually ping that. Okay, all right, and we'll talk through this in a second. So can we reach 4.1? And the answer is no. All right, we let the dead timer expire, and if you see here, process number 10, 5.1 on gigabit 2, full to down. All right, neighbor is down, and we cannot hit it. But are we able to hit one of our EIGRP interfaces? Not interfaces, but networks that are designed. So let's try this one. So we have 5.0 in our EIGRP section, right? So let's try to ping that. So can we ping 192.168.5.1? And yes, we can. All right, so EIGRP is still doing its thing. Are we able to still ping 2.2.2.3? And we can. All right, so we still maintain full connectivity. We have just said, listen, we don't want these protocols running on this network. And, to do that, it's pretty powerful. It's a simple statement that negates an entire routing protocol. So you can see how extendeds can be used a lot more than standards. So, you're not just dealing with IPv4 addressing. You're dealing with all kinds of things, routing protocols, ports, anything you put your imagination to and that your device will support when it comes to your access control list. So it's pretty powerful. And yeah, if we do real quick a show IP OSPF neighbor, obviously nothing's there. Okay, but once we come in and we'll go to int gi 2, and then we'll do no IP access routing ACL in, and what I'll do is no IP access, Control C here, Conf T, no IP access list extended routing ACL in. Oh, forget the in. There we go. Okay, and you didn't see it, or maybe you did, but as soon as we negated that ACL, our OSPF neighborship came right back up. So do show IP OSPF neighbor, and there our neighbor is again. So we're looking good. All right, great. And last, we're going to make this super quick because I don't want this video to go way too long. But we're going to talk multicast a little bit. Now, multicast is something that we'll get into more so in the future, but just for purposes of this, I just wanted to show you that you can block specific multicast addresses on your network using your extended numbered ACLs. All right, it's pretty simple actually. So what we're going to do very, very quick. So we're going to go ahead. What I've done here, I have Cisco IOS-V routers serving as multicast sources and multicast receivers. It just makes it easier. So what we'll do is we'll put our multicast configurations in there real quick. So for the first one, it's pretty simple. We'll just do T and then multicast routing. And then we will end this for now. And then the only command that we need here, we're going to use a specific address for our multicast groups. So what I'm going to do is we'll enable multicast routing, but then we're going to target our Gigabit Ethernet 00 interface, and we are going to assign it to a IGMP group. Okay, so as you can see here, we're going to take 0.0. This text is wrong here, don't worry about it, but this is interface Gigabit Ethernet 0.0 or 0/0, and we're going to do an ICMP join group 239.1.1.1. All right. So we should be good there. And what we could do is we'll go ahead and we'll put a debug for IP packets on here. Okay, and I'll show you why in a second. So for our actual routers themselves, our router 1 and router 3, what we need to do here is make sure that they are set up for multicast. Okay, we have to have multicast configurations for them to actually work. So we're going to enable multicast routing as a first step, and then we're going to assign our interfaces as PIM dense mode. Now we're picking dense mode only because we don't really have any rendezvous points, and we don't. It's just basically everyone knows about one another kind of thing, and you'll see why. The minute that I push this configuration in to both routers, you're gonna see, you're gonna see a DR change. All right, so I'm just gonna leave this as such for now, and then we'll do the same thing on router 3. We're gonna enable multicast routing, and then set both of our interfaces to PIM dense mode. All right, that makes sure that everyone's forwarding traffic. Okay, so the way that you do this is, so if we were to do a show IP route, we're going to see all kinds of stuff. We're going to see some EIGRP, we're going to see some OSPF, all that good stuff. So great. Now how do we see multicast? All right, because the address we're going to use is not in any of these schemas. So the command to see multicast is show IP mroute. And what we're going to do real quick, only because there's already been traffic that has been flagged, this may actually be left over. So what I'm going to do is I'm going to do clear IP mroute, and then you have to do an asterisk, okay? And then if I do a show IP mroute, we're going to see the single default that is assigned by multicast up front, okay? This address is nothing that really shows you anything, okay? And back on, I'm going to actually close these dockers real quick. Back on our multicast receiver, we can see that right now, since we've joined that PIM group, we're starting to broadcast out. All right, we're broadcasting and multicasting because we have joined the group and we want to know if we're, actually being tracked. So, with that being said, let's go ahead, and again, we have no entries here on router 3, which is over here. So on our multicast source, we're going to go ahead and do a ping 239.1.1.1, and then we're going to repeat this 10 times, okay? So we're going to repeat 10. So on our receiver, we are now seeing a bunch of traffic, okay? And you could see the source here is a unicast address of multicast source, which is here on the opposite side, okay? So it is seeing those pings. And, multicast is not exactly like unicast. We're not exactly just going to throw a reply back, okay? However, on router 3, now when we execute show IP mroute, we are actually seeing those entries, all right? So it is picking up 1.1.1.4. It's seeing the multicast address that's being pushed out. And then if you look at the actual flags that are associated with it, they're outlined here, but the SPT bit is set. We're not going to get into that right now because this isn't all about multicast. What I want to do is I want to show you how to stop it, all right? So I'm going to implement an access list, an extended numbered access list on router 3, and we're just going to deny that single address because I don't want it. All right, I don't want that multicast address going nuts and permeating on my network. So I'm going to assign an extended access list of 101, and I'm going to deny IP any from the host 239.1.1.1. All right, and then make sure that we put the implicit. I didn't put any remarks here because we're running out on time. All right, but from here, we're going to go back here. We're going to clear IP mroute with our asterisks. And then we'll do a show IP mroute. We see nothing. And we're going to come back to our source, and we're going to execute the same exact thing. All right, let's see what we got on the receiver. Huh, we're still seeing. Oh, I know why. Okay, because I forgot to assign it to an interface. So that usually helps. So let's go ahead and assign it to the incoming interface, which is Gigabit Ethernet 2. All right. And then once again, I'm going to clear IP mroute. Let's go back to our source. We'll repeat again. Now on our receiver, notice those debugs have all stopped. All right, they have all stopped. And on router 3, when we actually show our IP mroute, we're not seeing any of those entries that we saw before when our multicast source was throwing multicast traffic into the network. All right, this is just one example. It's pretty basic and upfront, but I did want to show everyone this to kind of show you the value of access control list. It's at your discretion. and really, it's a tool for you to use based on your customers' needs. It can come in super useful and handy when you need it. And I hope you learned something today. I appreciate making these videos. I learn along the way. I'm not doing this for money. If you subscribe, you subscribe. I'm not going to be those weird people on YouTube. I make these videos because they help me, and I hope that they can help others along the way too. So thanks for watching. I'll see you in the next one.